We present SkinCells, an automatic skinning weight computation technique with built-in sparsity and smoothness controls. Here we show our method applied on a variety of different character meshes with manually designed skeletons, all following the same range of motion sequence retargeted to each skeleton. Our method computes a weight field for each character that can later be efficiently queried at arbitrary levels of detail. The resulting field produces smooth weights with controllable number of non-zeros at each vertex, which is subsequently deformed using linear blend skinning. We recompute skinning weights using the bounded biharmonic method implemented in Houdini, which requires a tetrahedralized input for the solve. The complexity of this method causes failure on poor quality meshes indicated here in the missing spots. We compare our result on the washing machine character to the same setup using manually painted weights as shown in the character on the left. The biharmonic result in the middle is plausible, but deviates further from the artistic intent than our result on the right. Our method requires a skeleton rig and a corresponding mesh as shown on the left. We first initialize a Voronoi type structure, as illustrated in the middle, to produce a continuous weight field in 3D space around a skeleton in the canonical pose. Then, by sampling various poses on the skeleton, we compute a sample deformation using the current state of the weight field, as shown on the right. This allows us to iterate and minimize a set of objectives and penalize poor quality deformations using a gradient descent type method. Here, we apply our method to a set of skirts animated with dedicated skirt rig. Note that this sequence of poses was not used directly during the optimization. For cloth, we include an additional body penetration penalty to reduce the amount of interpenetration with the body. Although some interpenetration will persist since the shown body motion is outside of the training set. The method strikes a balance between stretching and collisions. We compare our method against robust skinning weight transfer shown on the left. Although this method is targeted towards loose clothing, it only binds garment to the body, which can cause stretching and interpenetration. We also establish a baseline for one-shot weight computation using a common distance-based method shown in the middle. Here you can see that our result has significantly less stretching and interpenetration artifacts than the other two methods. Thank you for your attention.